In this video, I'll show you how to solve the ALEKS problem called dosage rate calculations. There are two different versions of the problem. I'm going to show you how to solve this version of the problem, and I'm also going to talk about the other version as well. In this problem, you are given the size of a patient. I'm going to make a note of that. My patient in this problem is 56 kilograms. You are also given a dosage for a particular drug. In this problem, the dosage rate, which is going to be written as a conversion factor, is 5 milligrams of the drug, the medicine, per 1 kilogram of the patient or the person. So this dosage rate is a conversion factor between the mass of the patient and the mass of the medicine. And then it's also going to give you an amount of time that the patient needs to receive the drug across like a duration of time. So for mine, it is 60 minutes. And then last but not least, it is giving me a volume of solution that contains a particular amount of that drug. That is a concentration of the solution, and it is, for mine, it is 1 gram of the drug. When you're writing your concentration out, make sure you're writing the drug on top, the amount of drug on top, and the volume of the solution on the bottom. Mine is 250 milliliters of the solution that contains the drug. So this wants me to determine the rate in milliliters per hour that this drug should be administered. What I'm going to do with all these numbers that I've highlighted down here, I'm going to highlight the important ones. I definitely know that it's asking me about milliliters, so I know that this is going to need to show up in my answer. And it's also asking me about hours, which is a unit of time, 60 minutes, which we know is the same thing as 1 hour. So this is an important unit for me as well. So I've got all of this information. I need all of this information, but what I'm trying to do is do some unit conversions that are going to end up giving me answers, an answer with units of milliliters per hour. So the first thing that I'm going to do is figure out how much medicine this patient actually needs based on the patient's mass and the dosage. I'm going to start by writing the mass of the patient, which is 56 kilograms. I'm going to add patient there on the end. And it's important that you are pretty descriptive with your units because we do have two different mass units, so you make sure you're not getting them confused. 56 kilograms of the patient. I'm going to convert from the mass of the patient into the mass of the drug using this as my conversion factor. 1 kilogram of the patient, I'm just going to write patient's PAT, is associated with 5 milligrams of the drug. So in this step, I'm canceling out my units of kilograms patient, and what I'm doing is calculating the amount of drug that is needed for this particular patient. 56 times 5, that is 280 milligrams of the drug. That's how much this patient needs. And next, what I'm going to do is figure out how many milliliters of this solution are going to contain this 280 milligrams of drug. Now notice I have a little bit of unit incompatibility. I calculated the amount of drug in units of milligrams, and in order for me to be able to figure out how much solution I need that amount to be in units of grams. So before I proceed too much further, I'm going to take my 280 milligrams of the drug and I'm going to do a unit conversion. I'm going to get rid of the milligram unit, so I want that down on the bottom, and convert into the gram unit. Milli is the prefix for 10 to the minus 3. That means that I have 10 to the minus 3 grams in a milligram. Milligram unit will cancel, and I'm going to have 0.280 grams of this drug. That's how much the patient needs. So my next step is to figure out the concentration that is necessary to deliver this much drug. This is a unit conversion between the mass of the drug, 0.280 grams of drug, and it's a unit conversion between the mass of the drug and the volume of the solution. So I want grams of drug to be down on the bottom of this conversion factor so that those units cancel. I want milliliters of solution to be up on top. I'm just going to abbreviate that SOLN. And I'm going to be using this as my conversion factor. Notice that this conversion factor is not in the correct order that I want it in. I want grams of drug to be on the bottom. They are in this conversion factor, they're on top. So I'm just going to flip-flop the conversion factor, which is allowed. 250 milliliters for every 1 gram. This is going to cancel out my grams of drug. Let's do the math on this. 0.280 times 250. This is telling me that I need 70 milliliters of this solution. And it needs to be administered over a 1 hour period. The time is 1 hour. So let's plug all of this in. We have everything that we need. We figured out that we need 70 milliliters of solution. And our specified time is 1 hour, which actually works out pretty perfectly. And so my answer here is just going to be 70 divided by 1 is 70 milliliters per hour. Now, for the other version of the problem, it's actually looks really different, but it's actually not that different. The answer format looks pretty different. It gives you all of the same type of information, just like this. You can and you should perform all of these same calculations. So the key difference between this version and the other version of the problem, in the other version of the problem, it says like the drug needs to be administered over 60 minutes, and then it tells you, here's how much has been administered over the first 30 minutes. And what you have to do is calculate for the next 30 minutes, does the dosage rate need to increase or does it need to decrease in order to get the target? So you're going to be doing, in the other version of the problem, you're going to be starting by calculating how much drug the patient has already received, which is basically going to be starting here and working your way backwards to this step. You're going to do this calculation, and then you're going to do this calculation, and then you're going to do this calculation. So you're going backwards. And once you figure out how much the patient has already received, you are then going to figure out how much more the patient needs and determine if the rate needs to increase or decrease.